Pandas Notes 2, here we are again. So this morning we're going to look at working with subsets of data frames. And we'll start like we did before. Typical task, get NumPy and Pandas available, and then read the data exactly the same as in the last set of notes. Okay, now we start defining subsets, and we'll do things in two steps. We'll create a Boolean variable, and then we'll use the Boolean variable to extract a subset of the data frame. So the first Boolean variable we want to create I'll call November4 underscore bool. And it's true if the value of MO is 11 and the value of DY is 4 in the data frame. So go ahead and do that, and then come back and restart the video. But pause the video, go do your work, okay? Okay, you're back. I assume you've done your work, and let's see how this is done. It's np.logical and the two things that you're going to feed to np.logical and, the first Boolean expression is that the value of month in OA2 is 11, and the second thing that you're going to feed is the Boolean expression which tells you that the value of dy in OA2 is 4. So that's true for November 4th of every year, and it's not true for any other day. Task 4. Use the Boolean variable you just created to make a new data frame, NOV4 underscore DF data frame, by taking the correct days from OAW2, and then use the method info to verify your success. Is the number of rows correct? You still have all of the variables from the original data frame. Okay, stop the video, do your work, then come back when you're done, all right? You're back. I assume you're done. So the Boolean expression just goes here after the OAW2 in square brackets, and then we ask for info on November4 underscore DF. And what we see is we have 79 rows, 79 entries, and that's correct because remember this data frame began in 1941 and went through the end of 2019, so you have 79 years altogether. And yeah, as I remembered at least, these are all of the variables in the original data frame. Okay? Task 5, use the methods head and tail to see the beginning and end of the data frame. Okay, stop the video, do your work, come back when you're done. Okay, you are back. So I assume you're done. Let's take a look. So I put a heading in here, beginning of November 4 DF, and then it printed that out, and then the print, get a blank line. And then here's November 4 underscore DF dot head. And it begins with 1941, 42, 43, 44, 45, and all the months are 11, and all the days are 4. Okay? In the end, again, all the months are 11, all the days are 4, but this time the years are 2015, 16, 17, 18, and 19. Okay? Let's look at our next task. Repeat the steps above to create December 4 data frame. And obviously what you can do is you can just take the code that you wrote for getting November 4 and just change all of the NOVs to DECs and your work is done. But you got to stop and do your work, so please do your work and come back and restart the video. Okay, you're back. I assume you did your work. So here's the same code. The only difference is that MO is 12, DY is still 4, and of course the names are all DEC instead of NOV. And it's the same thing. You have 79 years from 1941 through 2019, and all of the variables are still there. So now you've got separate data frames, one for the November days and one for the December days. And we want to compare these to get an idea of how different the weather is likely to be a month from now when we're in early December. Okay, let's take a look. So use the method describe on both data frames. And then how do the values of PRCP, precipitation, Tmax, the maximum temperature, and Tmin, the minimum temperature, differ? And you can use the mean and median values to make your comparisons. And of course, the mean and median are alternative measures of central location of a collection of numbers. The mean, you calculate a mean, I'm sure you've all done this before, even in high school. Take all of the values and add them up and divide by the number of values. And the median is the location in the collection of values where half the numbers are lower and half the numbers are larger. Okay? And what we want to know is does December 4 tend to be colder and wetter than November 4 in Olympia? I think we suspect that's coming at us. Things are not getting any better, they're getting worse, right? This time of year. Okay, stop the video and do your work, and then come back, restart the video, and I'll show you my solution. So you're back. Let's take a look at my solution. So here's November 4, and down here, scroll down a little bit, there's December 4, the describe for both of them. First, let's look at precipitation. In November, the mean for precipitation is 0.207, and in December, the mean for precipitation is 0.214. That's not a real big difference, 0.07 of an inch of rain average per day. The median, here we have 0.098, so half of the days have less than 0.098 inches of precipitation. And in December, half of the days have less than 0.059. So the median has dropped almost in half. But the mean is about the same. And that's the difference is usually outlying values. And you can see what's happened here. We have a max of 2.27, and here we have a max of 1.94. Now let's look at temperature, the two temperature variables. First, in November, the mean temperature maximum is 54.97, about 55 degrees. And in December, the mean of the maximum temperature is about 46 degrees. So from 55 to 46, that's 9 degrees difference. So on average, you can expect December 4th to be 9 degrees colder than November 4th. And the minimum in November, the minimum mean value is 36.7, and in December, it's 32.7. Okay, so that's a difference of about 4 degrees. So the mean of the minimums is not changing as much as the mean of the maximums. You have about half the difference in the min degrees that you do in the max degrees. Okay? So that's a look at what's going to happen in the next month. So note that the describe method gave us information about the numeric variables, but it says nothing about the two categorical variables, warmth and wetness. And the reason, of course, is that these variables have character string values, so you can't compute statistics like mean and median. What you have to look at is the set of values that they take on. Now, Pandas provides you with a method value underscore counts, which we can use to see how the categorical variables differ between these 2 days. And use the value underscore counts method to see the contents of number 4 underscore df bracket warmth and December 4 underscore df bracket warmth, and describe the results. I take it you understand that all you really have to do is put dot value underscore counts after this thing. If you want to apply a method to something, it's just the something dot and then the name of the method with the parentheses. Okay, so go ahead and do that for both of those things, and we'll come back and take a look. So again, stop the video, do your work, and come back and look at the way I did it. You're back. I assume you've done your work. And in November, we have, of the 79 days, 72 were cold and 7 were warm. In December, every day was cold. Okay? So, yeah, December's going to be colder. We already saw that with numerical variables. Now we're going to repeat the last exercise for the variable wetness. So go ahead and do that, and when you're done, come back here and restart the video. So right now, stop the video, do your work. So in November, we had 35 really wet days. Note that these things come out in numerical orders, and in December we only had 28 really wet days. So it looks like the big difference is that the damp days, we only had 15 in November, and we had 23 in December. Interestingly, are about the same in dry days, 29 in November out of the 79, and in December 28 out of the 79 were dry. Okay? So the last question, these categorical variables were defined on the basis of numerical values. Particularly warmth has two values, and they're defined on the basis of the quantitative variable Tmax. And I did this myself, but for you to see how I did it, you'd like to see the maximum value of Tmax for days with warmth equal cold. So to see this, 2 steps. First, use OAW2, create a new data frame, cold underscore days, by selecting those days where the value of warmth is cold, and then use the method described to see the maximum value of Tmax in the new data frame. And then you'll see what the cutoff point is to call a temperature cold. And you may not agree with, you might not find that value cold. This time of year, we probably call that kind of value warm for a November or December day. Okay. So cold underscore bool. Again, we're doing this in 2 steps. A cold day is defined as one in which the value of OA2 warmth is cold. And then to get cold days as a data frame, you take OAW2 and you stick in brackets after it the cold underscore bool variable, and then you describe the resulting cold underscore days. And you see that the question that we were actually interested in is that the maximum temperature is 60.08. Okay? And because of the way this software works, you don't see the minimum temperature in this. If you do this in CoCalc, you'll see the minimum temperature as well, but it's actually suppressed in this printout. Okay, that's the end of the show for today.